right, before we start today's lesson, we're going to do a little bit of a review of finding the sum or difference of fractions. So if you recall, when fractions have the same denominator, we're just going to focus on the numerators. So this is going to become 1 plus 3 all over that same denominator of 5, which is 4 over 5. Number 2 is subtraction, but again, they're the same denominator. So we're going to end up with 11 minus 5 all over 12. So that's 6 over 12. And then we are allowed to reduce fractions, right? If the same number goes into the top and the bottom, we can divide by that. So that's really 1/2. But in number 3, we have different denominators. So there's 2 ways to go about it. We can think of finding the least common denominator, or we can look at the 2 denominators and break them down to their lowest factors, and whatever this one doesn't have, we're going to multiply that fraction by it, and whatever this one doesn't have, we're going to multiply that fraction by it, this fraction by it. So 3 and 5, there's nothing in common. So that means this top is going to get multiplied by what this doesn't have, the 5, and this top is going to get multiplied by what this doesn't have, the 3. And overall, my denominator is going to be made up of 3 times 5. So that's 10 plus 18, right? 5 times 2 is 10, 6 times 3 is 18, so that's 28 over 15. If this was reducible, I would reduce it, right? But that divides by 4, 7, 2, 14. This only divides by 3 and 5, so that's as low as that goes. All right, for 4, 10 is really 5 times 2, and 4 is really 2 times 2. So they have 2 in common, which means this fraction is missing the 5, and this fraction is missing this 2. So we're going to multiply this one by the 2, and this one by the 5. So that's going to be 18 minus 3 times 5 is 15, and it's over the common 2 times the 2 pieces that were individual, the 5 and the 2. So reducing this, we get 3 over 2 times 5 is 10 times 2 is 20. And doing this ensures that we already have the lowest we can go. If I had just done 10 times 4 and gotten 40 on the bottom, I'd multiply this by 4 and this by 10, I would have to still reduce. All right, so this is an easier way to do it to ensure that we're lower at the end result. So that leads us into our lesson today. We're still doing Unit 4, Section 1. This is the 5th day, and we're talking about Section 7.4, which is adding and subtracting rational expressions. So if I'm going to add and subtract, if they have like denominators, I'm just going to focus on the numerator. I'm going to add the numerators together, or I'm going to subtract the numerators, and they stay over the common denominator. So in our first example here, they both have a numerator of 4x. So my result will also be over 4x. And we're going to do 7 plus 3. So 7 plus 3 is 10. And now I'm going to reduce that. So 10 over 4 is 5 over 2, and the x is going to stay down here. Right? For b, they both have a denominator of x plus 6, so my result will be over a denominator of x plus 6. And we're doing 2x minus this entire thing of 3x plus 5. So the negative has to be distributed, so I'm just going to look at the top for a second. 2x minus 3x minus 5. So this is going to be negative x minus 5 over x plus 6. All right. You go ahead and try the next set. You can pause, and I'll show the answer. All right, so for number 1, the 8 minus 5 gave us 3, and 3 over 12x can be reduced to 1 over 4x. For number 2, 4x minus x gave us 3x over x minus 2. Nothing can be simplified. And in 3, 2x squared plus 2 is on top, but there's a GCF here, right? They both have 2 in common. So if we pull the 2 out, we're left with x squared plus 1, and now that actually cancels. So our final answer for number 3 is just 2. Then we're going to look at adding and subtracting with unlike denominators. So we have to have a common denominator between them. So I'm going to be doing these the same way I was doing my fractions earlier with unlike denominators. As long as they're fully factored, I'm just going to end up multiplying each fraction by the part it's missing. If they're not fully factored, I'm going to factor the denominator, look for anything that's in common, and multiply by the part that it's missing. So here in A, this denominator is x plus 4, this denominator is x minus 2. There's nothing in common, right? They're fully factored, they don't have anything in common. So that means the 6 is going to get multiplied by the bottom from here, x minus 2, and the 8 is going to be multiplied by the x plus 4, and the denominator is just going to be x plus 4 times x minus 2. So that's 6 times x minus 2 plus 8 times x plus 4 all over the product x plus 4, x minus 2. So I'll distribute, then I'll distribute, and then I'll combine my like terms. So 6x plus 8x is 14x, negative 12 plus 32 is plus 20. And what I would do here is I would just do a quick check. Is there anything I could take out? And if I do, will it look like anything on the bottom? So even if I took out a 2, I'd be left with 7x plus 10, which isn't going to cancel out. So I'm actually done. I don't have to go further than that. All right, if we look at B, same idea. These are both fully factored on the bottom. They don't have any parts in common. So the 10 is going to be multiplied by x plus 5. And the 3 is going to be multiplied by x minus 7. It's just subtraction this time. So I'm going to attach that negative to the 3. So we're going to have 10 times x plus 5 minus 3 times x minus 7 all over the product of my denominators, x minus 7, x plus 5. So distributing. Still all over the whole denominator. So we get 10x minus 3x is 7x. 50 plus 21 is 71. There's not even a GCF up there, so I don't have to worry about factoring further. This is my answer. All right, you go ahead and try the next two. You should pause and then you can check the answer. All right, so for number 4, we would multiply the first fraction by x minus 4, the second by x minus 2. So the denominator was x minus 2 times x minus 4. And combining our like terms, we got 4x minus 2 on top. If I tried to factor this, I could take out a 2, but then I'd be left with 2x minus 1, which doesn't cancel anyway. For 5, multiply the first fraction by x plus 3 and the second by x plus 10. I end up with 3x minus 33 on top. Again, I could take out a 3 if I wanted, and I'd be left with 3 times x minus 11. X minus 11 doesn't have anything to cancel with, so it's not necessary. One thing I do want to note is we usually will not multiply the bottom out to actually get a simplified polynomial. We're going to leave it in its factored form. Right? So don't ever do the extra work of multiplying these out fully when we're doing our adding and subtracting. All right. For our next example, we have two denominators that are not the same, but do have things in common. So I'm going to look at them one part at a time. So this, I'm actually going to start with this one. 3x squared is really 3 times x times x. And if I look at 6x, 6x is really 2 times 3 times x, right? 6 is 2 times 3. So they actually have 3 times x in common. The part that's different is the first fraction has a 2, and the second fraction has another x. So that's what I'm going to be multiplying the tops by. This top this numerator is going to get multiplied by this x. And this numerator is going to get multiplied by this 2. The bottom will be made up of the thing that's in common times the other pieces. So let's do this one step at a time. Let's do our tops, our numerators, x times x plus 2 minus 2 times x minus 9 over the one that's in common, 3x, times the 2 times the x. So now let's start to simplify. We'll distribute x squared plus 2x minus 2x plus 18. 3 times 2 is 6. X times x is x squared. All right, so this is a time I will actually multiply out. So if there was parentheses, if there was more than one part to the term, I would not multiply, but if it's individual pieces like this, I will. So x squared, the x's cancel, plus 18. So x squared plus 18 over 6x squared. And that is my final answer because nothing can be factored out of the top. So there's nothing to cancel out with the bottom. So you go ahead and try this very last one, pause it, and I will show the answer. Okay, so in the denominators, we had 7x to the third, so that's really 7x squared times x. We had 14x squared, that's really 2 times 7 times x squared. So both of them had 7x squared. This fraction had an extra x, and this one had an extra 2. So this got multiplied by the 2, and this got multiplied by the x. All right, and then the bottom was made up of the common 7x squared, and then the 2 pieces, the x and the 2. All right, so when I distribute and combine, I'm left with 2x squared plus 15x minus 2 equal over 14x to the third. And that is our lesson for part 1 of adding and subtracting polynomial functions.